Well, integration is basically summation of a series of multiples. Let's understand this with an example. Let's suppose there's a car which moves with a constant speed v for a time duration delta t. Now we all know that distance can be calculated as the constant speed multiplied with the time for which an object maintains that speed. So here we can calculate it as v multiplied with the time duration delta t. If you consider the graph of speed versus time, the car maintained a constant speed v for the entire duration delta t. On the speed time graph, v would be the height of the graph and delta t would be the width of the graph. And when you multiply v and delta t, what you effectively get is this area. And the area is the distance traveled by the car. So we can say that distance is the area between the speed graph and the time axis. And this is the proof for it, at least when the speed is constant. Suppose the car now moves with a speed v1 for a duration delta t1 and then moves with a speed v2 for a duration delta t2, and we have to calculate the total distance traveled by the car. If you want to use the formula speed multiplied with the time interval, which speed are you going to consider? Now this has to be done like this. If you want to calculate the total distance, you'll have to calculate it as the sum of the distances d1 traveled in the time delta t1 and the distance d2 traveled in the time delta t2, which you can calculate as v1 delta t1 plus v2 delta t2. Had there been a third interval delta t3 in which it travels with a speed v3, you would have added the third term v3 delta t3 as well. So this can effectively be written as the summation of v delta t or vi delta ti, where I ranges from 1 to 2, since there are only two terms. Had there been more terms, more finite intervals of time over which it maintains a constant speed, you would have added those terms as well. Now, if you consider this on a speed time graph, it maintains a speed v1 for a duration delta t1 and a speed v2 for a duration delta t2. And the total distance is the sum of v1 delta t1 and v2 delta t2. Now, v1 delta t1 is this area and v2 delta t2 is this area. So it is again shown to you that total distance traveled is the area between the speed graph and the time axis. So this complete area becomes the distance covered by the car. Now let's assume the speed of the car continuously changes with time. What we mean is that the car maintains a particular speed only for a very short duration of time, and the next moment the speed is something else. In that case, how do we calculate the distance? Since the speed of the car is continuously changing, there's no finite interval delta t over which the speed remains constant. All we can assume is that the speed remains constant for a very short interval of time, which is called an instant, and we represent it as dt. And the small distance that it covers in that instant would be v dt, where v is the speed for that instant. The next instant it has another speed. And if you want to calculate the total distance traveled in a finite interval of time, all you can do is integrate or put together or add up these multiples of v dt, just as we did in the previous case, v1 delta t1 plus v2 delta t2. Only here, we don't know the finite interval delta t. So we integrate these terms v dt from the initial time to the final time in which we need to calculate the total distance. So this is how you convert a normal multiple into an integral. And that is what we mean when we say integration is summation of multiples. So effectively what you're doing here is taking a speed v1 over a very short interval dt1 and then adding it up with a speed v2 multiplied with a very short interval dt2 and so on. And there are infinite such terms. Now let's consider this on a speed time graph. We need to assume a continuously changing speed. So I'm assuming the speed is continuously increasing like this. And let's say we need to calculate the distance covered by the car from the time t1 to the time t2. Now distance is speed multiplied with time, but the car does not maintain a constant speed over this interval. So what we do is consider the first speed, which is this height, and multiply it with a very short duration, which is the small time interval dt, over which it maintains that constant speed. So when you multiply the height with the small interval dt, which is the width, you get the area of this rectangular strip. And for the next instant, the speed is something else. And we multiply that speed with the next small duration of time dt, which gives us the area of the next rectangular strip. And you continue this process. So what you see here on the graph is each rectangular strip represents a v multiplied with a small time interval dt, and the summation of all those becomes the total area, which again is the distance traveled by the car in the time from t1 to t2, in the time interval t1 to t2. So you can say that integral v dt is the area between the v graph, the graph of speed, and the time axis. In general, integral y dx is the summation of y dx terms. So you can say, you can consider this as y1 dx1 plus y2 dx2 and so on, and there would be infinite terms that have to be added up. So we don't use the sigma summation symbol here, we use the integration symbol. So basically integration is summation of multiples like these. For example, we know the change in velocity is constant acceleration multiplied with the time interval for which an object maintains that constant acceleration. But if acceleration continuously varies, then the same thing can be written as summation of a dt terms. So integration is the summation of multiples. And this would also represent the area between the acceleration graph and the time axis. Let's look at another example where we can apply integral. We know pressure P is the perpendicular force acting per unit area. So if you ever want to calculate force from pressure, you can write force as pressure multiplied with the area. Now this is valid only when the pressure is uniform over the entire area A. But it's quite possible that the pressure varies from point to point on that area. Then how do you calculate the force? Now here we see that there is a multiple. Pressure is being multiplied with area, but pressure varies from point to point over that area. That is when you should get the idea that you can use an integral. So the force can be written as integral P dA. Now I'm not explaining how to integrate, but I'm just explaining why and when to use integration. Okay? So when two physical quantities are being multiplied and they are variable, you can convert it into an integral like this. Another example is intensity of radiation. Intensity of radiation is the power incident per unit area. So you can calculate power as intensity multiplied with the area. Now, if the intensity is uniform over the entire area, you can use this formula as it is. But if intensity varies from point to point over that surface, then you'll have to convert it to an integral and write it as integral IdA. So this is how you make use of integration. So go ahead, learn those formulas of integration and make use of this very powerful technique which will help you in solving problems.